Following on from the previous video, what it's saying is that for any given epsilon, then if you can find a capital N somewhere along here, where for all small n greater than capital N, so for all small n greater than capital N, where the sequence stays within these two lines. If you can find a capital N where for all small n greater than capital N, if the sequence stays within these two lines, then that means the limit exists. The limit exists. If the limit exists, then we say that the sequence converges. But then if you cannot find a capital N where the sequence stays within these two lines, then if you cannot find a capital N where the sequence is within these two lines, then we can conclude that L does not exist. We can conclude that the limit does not exist because you can't find a capital N such that the sequence stays within these two lines. Well, if you cannot find this capital N, then we can conclude that the limit does not exist. So if no such L exists, then we say that the sequence diverges. So for example, if you look at sine of x looks like this. If I give you an epsilon, let's say 0.3, you see you cannot find you cannot find a capital N somewhere along here where you see, if this is 0.3, you cannot find an N where, if you look at the difference of the two, it must stay within the tolerance. You see, for this, the limit doesn't exist. If the limit doesn't exist, then we say that the sequence diverges. So this sequence here actually diverges. If you look at this sequence, if I give you this boring sequence, let's say 3. So here, when n is 1 is 3, when n is 2 is 3, when n is 3 is 3, when n is 4 is 4, and so on. It will look something like this. Here, if I give you a tolerance of 0.2, say 0.2, then here you see the sequence is always within the tolerance. So for this sequence, we say that this converges because the limit exists. If you look at sine, there is no limit here. So there is so here capital L does not exist. If capital L doesn't exist, then we say the sequence diverges. Okay, so this bit here is saying if this sequence converges to L, we would write it as this. So we've seen this before. So for example, if we look at this, limit as n tends to infinity of 1 over n, then we can say that the limit here is 0. But then another way of writing it would be this. We would just write this. It would save a lot of time. We would just write this. We would just say this. This is a lot easier to work with than this. You have to write this lim thing, n tends to infinity all the time. It's a lot of work. So we would just write this. Okay.